Hello and welcome back to Rongmar. In today's maths lesson we're going to be looking at different kinds of lines. Our WALT for today is to identify, measure and draw diagonal lines, perpendicular lines and parallel lines. So without any further waiting around, let's just jump right into the lesson. Take a look at this shape here. This is a rectangle. The sides of this rectangle are perpendicular. What do I mean when I say that? Pause the video and write down an answer. So when we say the sides of the rectangle are perpendicular, that is because there is an angle of exactly 90 degrees at the point where they meet. You can see each corner has a set of perpendicular lines. These lines here are also perpendicular. The angles where the lines meet are both exactly 90 degrees. So simple question, what's a diagonal line? Pause the video and explain what a diagonal line is without a drawing. So we know what a diagonal line looks like, but what actually is it? A diagonal line does not have an angle of 90 degrees at the point where the two lines meet. The line below is at an angle of 135 degrees, so it's definitely diagonal. The sides of the triangle are also diagonal because they're at an angle of 60 degrees. Let's do a little bit of revision. Take a look at these angles down below. I've done the first one for you by drawing what I think 140 degrees looks like. Draw this picture and complete angles B, C, and D. Estimate what you think these angles would look like by drawing a diagonal line. Pause the video and give it a try. Right, let's see how close you got. So this is what the angles should look like. I wonder if any of you got near. Remembering that there is 180 degrees on a straight line, can you find the missing angle at each question mark? Pause the video and write down the answers for A, B, C, and D. So here's our answers. Angle A was 40 degrees, B 150 degrees, C 70 degrees, and D 115 degrees. So to find that, you get 180 degrees for a straight line, take away the angle you already know, and you're left with the answer. In this square, I've drawn two diagonal lines to connect the vertices inside of the square. In case you've forgotten, vertices, or a vertex if we're talking about one, is a point where two or more straight lines meet. So in this square, there's 4. Now when I drew that diagonal line to connect the vertices, I made some new shapes inside of the square. Can you describe the polygons that I have made? Pause the video and see if you can name them. Now, the polygons that you see inside are triangles. I hope everybody got that. But even more specifically, they're right angle triangles. Let's try another one. When I connected the vertices in this rectangle by drawing diagonal lines, I made some new shapes inside. Are these shapes the same as the ones inside of the square? Pause the video and name the polygons. So these are also triangles, but they're not right angle triangles. Instead, each triangle has got a pair of equal angles and a pair of equal sides, like this triangle A. Can you remember what triangle has these properties? Pause the video and write down the answer if you haven't already got it. Remember, 2 sides equal, 2 angles equal, it's an isosceles triangle. Let's have a look at one more. In this octagon, I have drawn a diagonal line to connect 2 vertices. Can you see the shape that I've made, the polygon B? What is the name of that polygon? Pause the video, write down an answer. Did you remember trapezoid? Before we finish, let's just make sure you remember how to find angles on a straight line. Take a look at this picture. Using everything you know about angles, give your best estimate at what these angles are. There's 3 of them. Pause the video, give it your best guess. So here's the answers. The first angle was 130, the second was 20, the last was 85. Were your estimates close? Or did you get any of them exactly right? That's all we have time for today. Until next time, take care.